I was a software development engineer at a media streaming company, working on the service that prepared personalized homepage recommendations. The service ran large overnight data jobs and kept substantial spare capacity because a missed run meant customers saw stale content the next morning. During a reliability review, I noticed our compute bill had risen by about £46,000 a month even though subscriber volume had grown only 8%. Finance had accepted the increase as the price of reliability, and the immediate proposal was a 1-year capacity commitment that would reduce the unit price but lock in the same usage. I believed we were paying for waste rather than necessary headroom. My objective was to reduce monthly compute cost by at least 20% while keeping job completion before 5 a.m., maintaining recommendation freshness above 99.5%, and creating no increase in overnight support incidents. I owned the analysis and changes within our pipeline. The broader commercial contract remained with finance. I broke the bill down by job, hour, instance type, and useful processing time. 3 patterns stood out. Development replay jobs copied full production datasets when most tests used only 2 days of history. Failed tasks restarted an entire partition rather than the unfinished segment. And the cluster stayed at peak size for 40 minutes after each stage because a conservative cooldown had been copied from an earlier platform. I validated those findings with the data scientists and the overnight support engineer. The scientists explained that model quality experiments sometimes needed 90 days, so simply limiting every replay would create hidden workarounds. The support engineer showed me 2 past incidents where aggressive scaling had delayed recovery. Those conversations stopped me applying a blanket reduction that looked efficient on a spreadsheet but would damage legitimate use and resilience. I considered purchasing the commitment, manually reviewing expensive jobs, or changing the platform defaults. The commitment saved around 12% but preserved wasted consumption. Manual reviews would be slow and easy to bypass. I chose to make the economical path the default while retaining explicit exceptions. For development, I changed replay requests to default to 2 days, displayed the estimated compute cost before submission, and required a reason for ranges beyond 30 days. I didn't require manager approval because that would add bureaucracy. Instead, weekly usage reports made unusual requests visible to the team. I also created a shared anonymized sample so common validation didn't need a production-scale copy. For failures, I added checkpoint metadata at segment boundaries and changed retries to resume from the last completed segment. The first version introduced a risk of mixing outputs from different code versions. I caught that in testing and added the build identifier to the checkpoint key, with automatic invalidation after deployment. For cluster scaling, I reduced cooldown in 5-minute steps while replaying 2 historical incidents. We settled at 15 minutes rather than the 5 minutes I originally expected, because shorter values slowed recovery during bursty storage errors. I rolled the changes out job by job and tracked cost, completion time, retry volume, and freshness for 4 weeks. I kept a rollback switch for each control. One research workflow regressed because it repeatedly requested the default 2-day sample and stitched results together. I worked with its owner to grant a documented 90-day profile, which was cheaper and more reliable than forcing the generic default. Monthly compute cost fell from about £168,000 to £119,000, a 29% reduction worth roughly £588,000 annually at the same workload. Overnight completion improved by 17 minutes on average because segment retries did less duplicate work. Recommendation freshness stayed at 99.7%, and support incidents did not increase. Only 6% of development replays used an exception range after the change. Finance then purchased a smaller commitment against the new baseline rather than locking in the original waste. The lesson I took from that was that sustainable cost reduction comes from understanding why people consume resources and redesigning defaults, not simply adding approval gates or buying a discount. If I did it again, I would put cost attribution and checkpoint ownership into the platform from the beginning. The most useful controls here preserved legitimate 90-day research and cautious recovery behavior while removing repetition that nobody actually valued.